Hello, my name is Krishna and I'm going to be teaching you the chapter 10 of physics, that is light, reflection and refraction. In this chapter we are going to be learning about reflection of light, okay? That is when the light bounces back on touching a polished surface. And uh, whenever we think about reflection, the first thing that comes to mind is mirrors, because mirrors reflect all light that is incident on it, okay? And spherical mirrors are they're spheres which are cut and they were made into mirrors. If we look at how light reflects on them, we will properly learn about how the reflection works. Okay, so we'll be looking at spherical mirrors. Then we will look at refraction of light, that is when the light passes through the object, like how the light passes through glass, like that. So now for refraction we're going to be looking at spherical lenses, because they explain the refraction. By looking at spherical lenses we can understand about refraction better. Okay, so the whole subject of science is basically about asking the questions why, what, how, to everything that we observe around us. We want to understand everything. So in this chapter we are going to be understanding light. Okay, now how do we see things, correct? So when it is dark we can't see anything, but as soon as we switch on the light, immediately we can see all the objects around us. Why does that happen? So when we switch on the light, what exactly happens that our eyes are able to see things, correct? We want to know why. Similarly, there are other questions like, why can we see through glass but we can't see through a wall? And how can we see so many colors? How is the rainbow formed? So some of the questions we'll answer in this chapter, and the others we will look at in the next chapter. Okay, so let us first start with the most basic question: how does the light move? It seems like a very simple answer, because when we hold a torch, uh, we know that the light only goes to where we are pointing the torch, correct? ನಾವು ಟಾರ್ಚನ್ನು ಯಾವ ಕಡೆ ಬಿಡ್ತೀವೋ ಅಲ್ಲೇ ಲೈಟ್ ಹೋಗುತ್ತೆ. ಸೊ ವಿ ಫೀಲ್ ಲೈಕ್ that light is traveling in a straight line. So people thought for a long time that light does travel in a straight line. So what they thought was, light is made up of small particles called photons. Okay, so there will be small particles all over in the light ray, and they travel in a straight line. This was believed for a long time, but then there are some experiments that are conducted by scientists called Young's double slit experiment, single slit experiment. These experiments showed that light doesn't always travel in a straight line. So when a very small object comes in the path of light, instead of traveling in a straight line, it takes a bend around it instead of traveling in a straight. This is known as diffraction. Okay, so what happens? What is going on here? In certain cases it is behaving like a straight line, in some cases it is not. So uh, by observing this diffraction, scientists thought that this will light actually moves like a wave, like this, instead of a straight line like this. Instead of that, light moves like a wave in a curved path. Okay, this was called the wave theory of light. For a long time there was confusion about this wave and particle theories of light, but now the modern quantum theory has been developed. This theory can explain why exactly sometimes light behaves like a particle, that is it travels in straight line, and why sometimes it behaves like a wave. But for this chapter we will be studying phenomena of light, that is reflection, refraction, and also we will see dispersion and all those things. But we will not study anything where the light has to deal with very small microscopic stuff like tiny hole or a small object. So that's why we will not notice the wave nature of light. For 10th standard, we will only be looking at the light when it is traveling in straight line. Okay, but this is just for your information that there is a wave nature of light also, but You will study about that in the next classes. In this 10th standard, you don't have to worry about it. Now let us look at reflection. Reflection of light is also a very common phenomenon. So when a light when it comes and touches the surface, that is a reflective surface, that is a polished surface like a mirror, what will happen? It will get bounced back. This phenomena is called as reflection. But also, where will it get reflected? When a ray comes like this, wait, uh, let me switch on the marker. Huh. Okay, so light has come like this. It could have gone somewhere like this, like this, like this. But why does it always go like this? Or sometimes it goes like this also. So we need to learn that, because if we don't know where the light will go, then we can't capture any image, correct? So for that, there are laws of reflection and laws of reflection. So these laws are what the scientists observed over a long period of time. They conducted several experiments, and by observing how light behaves, they have come up with these two basic laws. Okay, first one is angle of incidence is equal to angle of reflection. Let us see what that means. Angle of incidence is, so first of all we have to see what is a normal. Okay, so whenever there is a surface, we have to, at the wherever the light is touching the surface, we have to draw a straight line which is perpendicular to the surface. So this is 90 degree. Okay, so this angle should be 90. Okay, so this is 90. Now angle of incidence will be the angle that the incident ray makes with the normal. Angle of reflection will be the angle which the reflected ray makes with the normal. This is denoted by I, this is denoted by R. Okay. Now the first law states that angle of incidence is equal to angle of reflection, which means when this comes in and falls on the mirror in this particular point, it can only go in one way. That way is when it makes angle of reflection equal to R, which is should be equal to I, right? So now if the light ray actually has gone like this, what will it mean? Which then it will mean this will be the angle of refraction. Then this is IR, this is I. So angle of incidence will not be equal to angle of reflection. So it will not follow the laws of reflection, which means light will not get reflected like this. So the only way the light will get reflected is like this. So see how important this law is. From this law we can exactly tell where the light will go. The second law is that the incident ray, the normal, and the reflected ray at the point of incidence all lie in a same plane. What does same plane mean? It means this one, incident ray, normal, reflected ray, at this point, that is point of incidence, it will all lie in the same plane. Same plane means you can actually draw all of this on a sheet of paper. If you consider this a sheet of paper, sorry for my drawing, I'm not able to draw proper straight lines. Okay, so let us consider this a sheet of paper, which means this we can draw it on a sheet of paper. See, if you have something like a cube, okay, cube we can draw a square on a paper, but can we draw a cube? We can't. No, we can just do something like this and we can feel like it is a cube, but it actually, we have just imagined it like this, but we are not able to actually draw it because it is 3D, and on paper we can only do 2D. Here also there is no ray that is going to be coming out of this paper. We can do it inside itself. So all of these lie in the same plane. Okay, These are the two laws of reflection, and both of these will be followed, and they will be very important to determine where the light will go. We will see in the further part of the chapter that using these laws we can exactly predict where the image of the where any image of object will be formed after it touches the mirror or a lens, and based on this we can, you know, predict where the image is formed, and we can put a, if the image is formed there, we can put a screen and we can look at it, right? That is how camera actually works. So when we know where the image is going to be formed there, if we place a screen, that image is going to be captured there. Okay, now let us look at image formation. Okay, what is image? First of all, image is how is it formed? So image, so each object that we can see, we are able to see only because the image of that object is formed inside our eye. So we told, no, in the introduction slide, how are we able to see things. What happens is, when a light is reflected from an object, that light will enter our eye and it will form an image inside our eye. Okay, then that image we are able to see. Here, let us look at it. So how are images formed? Images are formed when multiple rays of light that are reflected from an object intersect. Okay, so here in this image, see, there are multiple rays of the sun which are coming to the magnifying glass. What it does, it will focus, it will bend the light after passing, it will bend like this. Okay, and it will form an image here. This is the image of the sun. Why is this image coming? Because all this light is coming and intersecting here, correct, no? So when multiple rays of the object intersect after reflection, then we can see the image. This is actually image formed because of refraction, not reflection, but still image is formed only when rays intersect. Okay, this is one very important point to remember. Now let us see what is a real image and a virtual image. Image that can be captured on a screen is called as real image. Okay, so this image of the sun is being captured on this wooden piece, correct? So then this is a real image because we are actually able to put that image on something, some real world object. But if you see an image that is formed inside the mirror, you can't take it and put it in any object, correct? We cannot capture that image on any real object. So that is so see here, what happens is, if there is a real tree, the light from the tree, so from the sun, light will come here, it will get reflected from the tree, it will fall on the mirror. Okay, then from what a mirror do, mirror will just reflect, because it will not, light will not go inside because it is polished surface, so it will reflect. Similarly, multiple rays we have drawn. Now what happens is, when they reflect, for our eyes it will seem like it is coming from behind the mirror. Actually it is here, but for our eyes, because the light has come in a reflected manner, it will appear as if the image is inside the mirror. So this image is actually a virtual image, because it is not formed by actual intersection of rays. It is formed only because we feel that it is intersecting. Okay, so this is a virtual image. Now that we have seen what image formation is, what are real and virtual images, I think we can go and look at spherical mirrors. Spherical mirrors are, okay, let us assume this is a hollow glass sphere. Okay, what we will do is, we will cut it in half, and for one part we will silver the outer surface, for other part we will silver the inner surface. What will happen now? This is glass, this is silver, this is silver, this is glass. Now concave surface, for concave mirror, the light will come like this, it will get reflected, come back, right? It, and convex light will come like this. So when the uh, hollow surface of the sphere is made as reflect is where the light is falling, that is called as concave surface. When the light is falling on a bulged surface, then it's the convex surface. If you take a spoon, okay, the side of the spoon from which you eat is the concave surface, but the opposite side of the spoon where it is bulged is the convex surface. Okay, this there is a this is the concave surface, and the point, the center of the circle of which this surface was a part of before is called as center of curvature. Here also we can see this is a convex surface and this is the center of curvature. This is also a part of the whole. This was also a part of the sphere, correct? Actually, to look at this in detail, let us look at a video.
Circles. Being a part of a circle or sphere, both of them are bound to have a center. This is called the center of curvature. It is denoted by the letter C. As is the case with any circle with a center, the distance between C and any point on the mirror is called the radius of curvature. It is represented as R. The point on the curve of the mirror, which divides it into two equal halves, is called the pole. It is denoted as P. Now again, as P is on the circle, the distance between C and P is also R. Beyond this point, we have to use a little imagination. It's not difficult at all. Let's take it one step at a time. Just like how we had a normal earlier for reference purposes, let's now again have a line that passes through C and P, which sort of bisects the whole mirror curve. This line is called the principal axis. All rays incident onto the spherical mirrors will now be compared to the principal axis. Now along these lines, let us imagine a beam of light which has all rays parallel to the principal axis incident onto both the concave and the convex mirror. As mentioned before, in the case of the concave mirror which focuses light, the rays of the beam will be focused onto a point. This point is called the focus. In the case of the convex mirror which diverges light, the rays of light will appear to diverge from a point. This is the focus for the convex mirror. Thus, keeping what we understood earlier in mind, we can say that the concave mirror has a real focus while the convex mirror has a virtual focus.
This much is enough. So I showed you the video so that it will be easier to imagine, correct? So we learned that pole is the geometric center of the spherical surface of the mirror, correct? Center of curvature is the center of the sphere of which the mirror is a part. Principal axis is the straight line passing through the pole and the center of curvature. We also saw in the video that for concave mirror, the focus is the point where a light ray traveling parallel to the principal axis, when it hits the mirror, wherever it touches the principal axis, that point is called focus. Similarly, wherever it appears to touch the principal axis, and for a convex mirror, that is the focus. Okay, now let us look at the rules of reflection of light. Let us look at the textbook for this. Yeah. There are actually 4 rules, okay? Now what are these rules? So first of all, we'll study that there are 2 laws of reflection. Laws of reflection will exactly tell us where the light will be reflected. Now based on these laws of reflection, when we apply those laws on spherical mirrors, we can develop some 4 basic rules so that we can easily predict where will the image will be formed. So these rules are developed by performing several experiments. Let us look at the first rule. Here for a concave mirror, when a ray parallel to principal axis comes and hits the surface, where will it go and touch? It will obviously touch the focus, because the definition of the focus is only the point where a ray parallel to the principal axis will touch the principal axis. This focus is usually, not always, but usually in between center of curvature. In between means exactly in the middle of center of curvature and pole. And focus obviously will always lie on the principal axis. Now, how did this rule be formed, right? How did we make this rule? First of all, when this light comes and touches the surface here at this point, how do we know where the light will be reflected? We can figure that out by applying the laws of reflection. For the law of reflection, first we have to do normal. Before the normal was easy because it was just a straight surface, so we can, let us look at that once. So here drawing a normal was easy because this surface is plane. Simply if we draw line perpendicular to it, it was over. But now it is sphere, right? So now drawing a normal is little more difficult. What we should do is, for drawing a normal, wherever the light touches the sphere, at that point we have to draw a line which just touches the circle. Okay, this is, see this line just touches the circle at this point. So now for this line at this point we have to draw a line perpendicular. So this is 90 degrees. This is the normal. Now with the normal, it is making angle of incidence I. So where will it get reflected? It obviously has to get reflected here only. Okay, similarly for a convex mirror, it will get reflected like this. Normal we have to draw, first we have to draw the plane surface which is just touching the circle at this point, and then we will draw the normal to the surface, and then we can easily tell where the light will go. Okay, so these rules are all formed based on the laws of reflection only. So first rule over now. So what was the first rule? Whatever ray comes parallel to the principal axis, when it touches the mirror, it will get reflected back and touch the focus. Okay, let us go down to the next. Now the next rule is, a ray passing through the principal focus of a concave mirror, or a ray which is directed towards the principal focus of convex mirror, after reflection will emerge parallel. Okay, see, if a ray is traveling through the focus and it touches, again we can draw a line which just touches the circle at that part. It's little difficult. Okay, and then see, normal we will draw, and this is the angle of incidence. It has to come like this, so it will become parallel to the principal axis for concave mirror. For convex mirror, it will, if it comes, see, for convex mirror, the focus is on the other side of the mirror, correct? So light cannot come from here. So light appearing to come from the principal focus will get reflected parallel to the principal axis. Okay, if you are getting too confused with the convex mirror, it's okay, don't worry. Just focus on the concave mirror for now. It is very easy to understand. After you are completely comfortable with it, then you will easily be able to apply the same concept in the convex mirror. Only here it is going to be appearing from, okay, but this is because, since this is easy to understand, let us only focus on concave mirror now. Next rule, a ray passing through the center of curvature will be directed towards the center of curvature after reflection also, correct? Now How is this? If a light ray passes through the center of curvature and reaches the mirror, it means it is traveling the path of the radius of the circle. What is the normal here? Normal is, let us draw again. At this point we should just touch that point and draw it. Now what is the normal? This itself is the normal, correct? No, so this itself is the normal. Because of this, what is the angle of incidence? Angle of incidence, let us see here. When a light ray comes like this, this is the normal. This, if the light ray is coming like this is the angle of incidence. So now if the light ray is actually coming like this, then angle of incidence will be 0, correct? No, okay, sorry for I'm not able to draw equal to easily. Okay, so because now the angle of incidence is 0, what should the angle of reflection be? It should also be 0. So it has to travel back in the same path that it came. What is the next rule? Next rule is incident ray that is obliquely incident obliquely to the principal axis towards the pole, okay, is reflected obliquely again. This is an easy rule actually, correct? Now this is obvious because an incident ray that is coming to the touching here, we will draw normal here. First we have to draw the plane surface. So just it should just touch actually, but here it is touching more points. Wait, let me reduce the size of the pencil. So it should only touch the circle at this point. We draw normal here. Angle of incidence, angle of reflection. Okay, so obviously the light will travel like this. So these are the 4 rules. They're actually pretty simple. Is it? Now because we know the laws of reflection, we can easily figure it out. What are they? If it is traveling parallel to the principal axis, it will get reflected and it will touch the focus. Okay. Second one, if it is traveling through the focus, after reflection it will become parallel. Third one, center of curvature, if it goes through, then it will reflect back, correct? Then similarly, ray incident obliquely towards principal axis will obviously get reflected like this. So these are the 4 rules. You should remember them. Okay, in the exam also they can ask this. You should remember the ray diagrams also, like what will happen, correct? And in the exam it might be difficult for you to draw the normal and all. Okay, so it's better to remember the diagrams little bit. If you, at least if you remember, it will be easy to draw in the exams. So now after this, we can apply these rules to figure out where the image of the object will be formed. This is really interesting because now see, you would not have tried this out at home. It's difficult to try it out at home. Okay, so whenever there is a concave mirror, what will happen when you keep an object and if you place a screen here, like if you keep an object like a pencil here, and then if you keep a screen here, that is maybe a wood or something, you can actually see that this object's image will be formed inverted at this particular point. Okay, so this is actually these rules will help us figure out where will the image be formed and how will the image look. Okay, this is really interesting. Let us look at how this is done in the next video.